Hello everyone, I'm Miga and welcome to my channel. So today we will talk about the Newman projection. So first, let me introduce you to a molecule that I built. Again, you can build it too if you have the kit. These are the typical color you would see in the kit. Usually black. The black color is for carbon, so I kept it that way. White usually is hydrogen, and red most of the time is oxygen. But because I'm not sure about the bromine color, so I just picked purple as bromine, but it might be different in your kit. Let's say the professor asks you to draw the Newman projection along the C2, C1 bond, carbon 2, carbon 1 bond. So first you need to number your carbon. So if you're not sure about the nomenclature, let's not focus about this in the video. The purpose, which is to learn how to draw the Newman projection, should work. Even if we decide to start this way or the other way, because this is not a naming video. I'm just doing it to show you how the different step to draw the Newman. Okay, so here with number of carbon, again on the right, I put the same structure that is more familiar to what you should see in a book, right? So 1, 2, and 3, carbon 3. I already put the 3. I didn't even see that 3, right? The same thing. Okay, so the professor is asking us to look along C2, C1 bond. Usually, I like to stay consistent with my method. So I like to pick the first carbon they put, right, as the front carbon. So basically, what I mean is that that's where I will be looking at. So if we put an eye here, right, that's my eyes, looking straight along the C2, C1 bond. It should work here too, same thing, the C2, C1 bond. You see, my eyes is looking at this bond here. Let me put this in purple, this bond here, same thing, okay? All right, now let's go on the next page. Like I said, if we're looking at C2, C1 bond, guys, what do you think you would see? Let's try to visualize what exactly we would see in front of us. So here we have front view. Let me draw exactly what I'm seeing. So first we have a ball, right? The black ball of carbon 2, right? So that's carbon 2. Let's put carbon 2, right? And then I'm seeing that carbon 2 is attached to hydrogen, sticking like this. Again, that's just the front view. What the eyes is looking at is seeing something like this, right? CH3, right? This group here. And we have the 2 hydrogen here, right? There is the same one here. And then my eyes can't really see that one, because if I'm looking straight to it, it's like the carbon 1 in the back, it's blocked by carbon 2. However, I can see those groups sticking out. So let's do the same thing. Let's draw, and let me do it in gray or light gray or something that shows you it's in the back, right? So I'm seeing something like this stick out. Hydrogen like this stick out, and I'm seeing these 2 other groups. So we have the OH in the back. So let me draw the OH in the back. And we have a bromine. That's what my eyes is seeing, looking straight to carbon 2. And guys, that's exactly what the Newman projection is all about. So let me put Newman. Let's draw the Newman projection. Remember, I'm just gonna recreate what my eyes is seeing. By the way, remember this group in the back? It's in the back. It's in the back. It's the same one as that group here. Remember, I can't really see carbon 1. It's hidden in the back. This group here, you will represent it just as it is, like this, and like this. We're not gonna change anything about that. That will be for my group in the front. So let me place everything. We have the CH3 group here. But The Newman also says that for the group in the back, especially carbon 1, the carbon that is holding all those group in the back, that carbon 1 that is holding this hydrogen, this oxygen, this bromine, because normally it's hidden, we're gonna enlarge it a little so that it's easier. We know that's why it is. So you know what? Let's put some color to this carbon, okay? I don't like the gray. So this one in blue, we're gonna enlarge it. Again, that's carbon 1. That's carbon 1. Okay, that's carbon 1. In blue, we're gonna enlarge it so that we know that that big ball, that big circle is carbon 1 in the back. We just enlarge it because otherwise it would be hidden and we don't want that, right? And we will place those group in gray like that, right? So we have H. Again, we will place our OH group the same way, and of course, our bromine, okay? And that's really what it is for a Newman projection. So now that we have an idea about how to go from a simple representation, right, to the Newman projection, right, we're gonna do some practice, going a little faster now. Let's say they ask us to draw a Newman projection along the C2, C3 bond of the following conformation of 2-butanol. Again, I found this in a book and it was nice that they show us this molecule, but guys, most of the time, the teacher isn't gonna give you this representation. So let's do a line bond structure, something that is more familiar, but to do that, let's number our carbon. So we have 1, 2, 3, 4. So 1, okay. We have 1, 2, 3, 4 carbon. I like to count. So carbon 1 is attached to 3 hydrogen. We don't need to represent it. It's a line bond structure. Hydrogen are not represented. We have an OH group, right? Which is OH group here. But and not only that, it's in the front. So we're gonna represent it in a wedge. Again, you don't have to worry about those representation now. We will worry about it another day. Okay. And then carbon 3 is attached to 2 hydrogen. Hydrogen are here. They are simply not represented, right? And then carbon 4 is attached to 3 hydrogen. But again, we don't need to draw them. We know they are here. Okay, so once we have this molecule, that's what you should expect on the exam or on your test or homework. So let's use this to draw along C2, C3 bond. First, always number your carbon to know what carbon they're talking about. 1, 2, 3, and 4. The professor asked us to draw along C2, C3. So C2 will be my 4th carbon. So this is it. So this is the bond we're gonna focus on, right? Let me draw my eyes like usual so that I can see, I can visualize it in my head what the professor is asking me. So this is what I'm seeing. This is my front view. And to help, guys, remember, since OH is in the front because it's on the wedge, we know there's another group in the back, right? Because usually carbon can have make 4 bonds. If you don't know what I'm talking about, then I'm gonna make another video about that because this is doing my first video for the channel. But usually carbon can have 4 groups, guys. There's the hydrogen in the back, okay, that we're gonna place here. We have an hydrogen here, okay. And if you don't believe me, look at this. There's an hydrogen here. So that's the same one I'm putting in the back. It's gonna be helpful to draw the complete Newman projection. Okay, so here we have this one here. And let me visualize what I'm saying. So this will be carbon 2, right? Let me put this bigger so that you can see what I'm talking about. So it can be carbon 2. And carbon 2 is attached to 2 groups that is pointing out and 1 going down, right? This one should be CH3 group. and we have OH and H. Now, guys, I'm gonna say that you're gonna have to turn your head so that you can visualize which one is on the right and which one is on the left, right? Imagine, let's do this. Turn your head, follow my eyes, right? Turn your head to the right and try to see, like, can you visualize the OH being on the right and the hydrogen group being on the left? If we were looking at it, right, following the brown eyes that I draw, you would see that it's right. It's right of the eyes, right? And the hydrogen is on the left side. That's why I would put the OH on the right and the hydrogen on the left. And again, for the back, let's see. Guys, I think for this one too, I like to put some groups so that I don't forget any compound, right? Any element. I like to put everything that something's attached to so that I don't forget any element. In this case, I know there's 2 hydrogen on carbon 3, attached to carbon 3, right? So, and I see that they're pointing down, so I'm gonna put them going down. Here it's easy, we can just add them. I'm just gonna add the hydrogen here, right? And of course, we have a metal group. Guys, do you see how this metal group, this CH3 group is right in between? Would you see how it's in between the OH and hydrogen? So I should see it in between too. So I would see something like this, right? So once you have this, again, I'm showing you step by step what I'm seeing when I'm visualizing, why I will be drawing the human like this, right? But some people will want to go from this to the Newman projection that we will be drawing, Newman projection. By the way, that's front view that I'm seeing, that the brown eye is seeing, right? So Newman projection, quickly, the front should remain the same. So we have HOH and CH3, right? And then in the back, remember, the back carbon should be enlarged. It should be bigger. So we're gonna, like a nice circle, and we're gonna place the group, the back carbon, which is carbon 3, is attached to. Also, we can go in reverse too. So let's say the professor gives you the Newman projection and ask you to draw the line structure of this compound, right? Of this molecule, right? Okay, we can do that. Usually I always like to focus on the front carbon and the back carbon. Okay, so first let me draw a line. I always draw a line. Now, what are the compound, what is attached to this carbon here in the front? So let's see, the front carbon is attached to a metal group. So let's do this. For now, let's draw everything. Okay. After we see that we have a CH3 on the left and an hydrogen on the right. Again, here, I'm gonna have to put a small eyes. Let's put an eye here. Once I have my eyes here, I can visualize, I can turn my head and think, okay, my left side should be sticking into the page. So in the back, so let's do it on the dash, CH3. And my right side, the hydrogen should be sticking out of the page in the front. So we can put the hydrogen here. Oh, let me withdraw this so it's nicer, CH3, okay? Again, we can always write our font here. And for the back carbon, the circle, this one here. Again, according to the brown eyes, the left side of the brown eyes should be sticking into the page. So let's in the back like this. So They put CH3. We should have the other one sticking out, going in the fourth, which is CH2, CH3, and we should have the other one going down, CH2, CH3, which is another ethyl group. And again, I like to quickly see if it matches my picture. For example, here, between the CH3 group and CH2 group, I should have a CH3. And look at these guys going in it. We can see the CH3 is sticking in the middle. Same thing for this ethyl group here. We can see that it's sticking in the middle of the the metal group and the hydrogen. You see metal group and hydrogen. So that's why I know it's good. And again, if the professor doesn't care about showing the stereochemistry, we can do a simple line structure. So first we can draw the front and back carbon. Remember, this the bad carbon. So front and back. I'm just gonna show the line. So we have a CH3 in the front up, sticking up, another CH3 sticking down. And in the back carbon, we have one CH3 this way, and we have two metal group. So two ethyl group. As a matter of fact, let's draw the ethyl first because they are bulky. And so we have an ethyl group here, we have another ethyl group here. We can add a CH3 group like this. And then that's all I have for the Newman projection. Thank you for watching my video, and remember, keep practicing until you understand, you know the material, so that you can move on to the next topic. See you on the next video.